Here we're going to solve a system of equations using matrices. The method that we use when we solve a system of equations with matrices is typically called the Gaussian elimination method. Now, I have a system of equations here that we're going to solve. 2x plus 3y equals 1, negative x plus y equals negative 3. And I know that you might already know several different ways to solve this system of equations, maybe substitution or graphing or the addition elimination method, but we want to practice with matrices with some smaller sets of equations. So first, what is a matrix? A matrix is just a collection of rows and columns of numbers. Now, there are many ways to write matrices. In this set, I'm going to write matrices, what we call an augmented matrix, using brackets on either side. And each row in this matrix corresponds to the coefficients of the first equation in the top row and the second equation in the bottom row. So for the first equation, we have 2x plus 3y equals 1. I'm going to write the coefficients 2, 3, and the constant 1. And to represent the equal sign, I'm going to put the equals bar down there. That's what makes it an augmented or a separated matrix. In the row beneath it, let me write these coefficients in. Negative 1 for the x and 1 for the y, making negative 1, 1, and negative 3. So the top row in my matrix corresponds to the first equation. The bottom row in the matrix corresponds to the second equation. The first column corresponds to the coefficients of the x's. The second column, the coefficients of the y's. The bar is the equal sign, and then the constants are on the other side of the equal sign. So you might recognize the word elimination in Gaussian elimination from the previous section where we added two equations together to get zeros for the x or zeros for the y so we could solve for the other variable. That's really similar to what we're going to be doing here. So let me show you really quickly what our goal is going to look like. Our goal is going to look like getting the augmented matrix 1, 0, let's say A, and 0, 1, B. Now, remember what I said, the first column of coefficients goes with the x's, and the second column goes with the y's. The bar corresponds to the equal sign, and the A and the B on the other side correspond to our constants. So this first row corresponds to 1x plus 0y equals A, which if I simplify it, means x equals A. The second row corresponds to 0x plus 1y equals B, or in other words, y equals B. So if we can get this matrix to look like this matrix, we have x equals A, y equals B, really clearly visible in the last column on the right-hand side. So our goal is to get 1, 0, 0, 1 on the left-hand side of our matrix. And here's how we're going to do that. We're going to get to use 3 different row operations. And let me list them out here. So the 3 row operations that we can perform on any of the rows in our matrix are this. We can switch any 2 rows. Now remember, each row simply represents an equation. So if I switch row 1 with row 2, it's kind of like writing 2x plus 3y equals 1 versus negative x plus y equals negative 3, or negative x plus y equals negative 3, and 2x plus 3y equals 1. I'm just switching the order of the two equations. So since changing the order of the two equations won't change the solution, changing the order of the rows won't change the solution. Okay, second thing that we can do is just like in, let me only erase part of this, just like in any equation, just like in any equation, we can always multiply or divide any number by both sides. We can multiply or divide 2, let's say, by both sides of an equation 1. Then whatever happens to an equation is what could possibly happen to a row. So we could also multiply or divide any number that we want to each entry in a row. And the third thing that we can do, just like when we were using the elimination method, is we can add two equations together. So for a matrix, that's akin to adding two matrices. I'm sorry, adding two rows together. So those are the three things that we can do with a matrix. We can switch any two rows, we can multiply or divide any number to each entry in a row, and we can add any two rows together. Now remember, our goal is to get 1, 0, 0, 1 on the left side of our matrix, where the 2, 3, negative 1, 1 is. So I want to give you a really big piece of advice. When you're doing that, when you're getting your 1, 0, 0, 1, it's really important that you start in your first column, getting your first 0 where this negative 1 is. So I want my first 0 to be the zeros from the first column. Okay, let's clear all this out so we can start doing that. Okay, so how are we going to do that? Remember, we can add two rows together. Well, right now, if we add these two rows together, nothing is going to add up to a 0. But much like in the elimination method, if we had this instead of a negative 1, say as a negative 2, when we add 2 to negative 2, we would have a 0. So here's what we're going to do. We're going to take row 2, and we're going to multiply that by 2. And when we do that, we're not going to change row 1. So that will give us 2, 3, 1, still for row 1. But 2 times row 2 is going to be negative 2, 2, negative 6. Okay. Second thing we're going to do is we're going to take row 1 and add it to row 2. And we're going to store that result in row 2. So 2, 3, 1, we're not going to change our top row, but we are going to add the two rows together and store that result in row 2. So 2 plus negative 2 is 0. 3 plus 2 is 5. And 1 plus negative 6 is negative 5. Awesome. We did what we wanted to. We got a 0 in that first column. Okay, before we move on to get a 0 in this spot right here, there's one thing I want to point out. We can, don't forget, multiply and divide, or divide each side of each entry in a row by any number we want to. And if we look carefully at that second row, 0, 5, and negative 5, I want to notice that all of the non-zero entries in there are divisible by 5. So in order to make our numbers smaller, I'm going to take row 2 and divide it by 5. And I'm going to store that in row 2. So that will look like 2, 3, 1. We still haven't changed row 1 at all. Dividing everything in row 2 by 5. 0 divided by 5 stays 0, which is great. 5 divided by 5 is 1. And negative 5 divided by 5 is negative 1. I love that result because we didn't end up with any fractions by doing that division. Great. Okay, the next step is to get a 0 here where our 3 is in the next column. So our first step, remember, was to get a 0 where in the first column where the negative 1 was, and now we want to get a 0 where the 3 is in the second column. And I'm going to do this a little bit more quickly than I did in the previous one because it's just like the elimination you guys already practiced. So if we're going to do the same thing we did with elimination, multiply rows by any number we want and add rows together, and we want a 0 where this 3 is, if we just multiply row 2 by negative 3, make this a negative 3 down here, and add that to row 1, storing that result in row 1, we should get a 0 where our 3 is. Okay, so we're going to multiply row 2 by negative 3. So I'm going to record that here. 0 times negative 3 is 0. 0 times negative 1 is negative 3. And I'm sorry, 1 times negative 3 is negative 3. And negative 1 times negative 3 is positive 3. I just like to have those there so I can do my arithmetic more easily in my head. So here's what we've got. We're not storing this answer in row 2, so I'm going to leave row 2 as 0, 1, and negative 1. We're storing this result in row 1. So let's see, adding those green numbers to the black numbers in row 1, so the negative 3 times row 2 here to the row 1 entries up here, we have 0 plus 2 gives us 2. Negative 3 plus 3 is 0. And then finally, 3 plus 1 is 4. Great. We are one step away from being finished. We have the 0, 1 already in the second row, and we have 2, 0 in the top row. So the last thing that we need to do is take row 1, divide it by 2, and store that answer in row 1. So we're storing our answer in row 1, so row 2 will not change. 0, 1, negative 1 stays. But dividing every entry in row 1 by 2 gives us 2 divided by 2 is 1, 0 divided by 2 is 0, and 4 divided by 2 is 2. Terrific. And if you remember from the beginning, this corresponds to the equations, let's see, 1x plus 0y equals 2, or in other words, x equals 2, and 0x plus 1y equals negative 1, or in other words, y equals negative 1. So if we can just look at this column right here, x equals 2 and y equals negative 1 is our answer. And we do not need to write those sets of equations in. We can just look at that last column right there if it's in reduced row echelon form. Let's do one more example. Okay, first step is to put this into a matrix form. So writing our matrix as our coefficients, we have the coefficients of the first equation are 1, negative 2, 2. And the coefficients of the second equation are 3, negative 5, 9. just like in the last example, the first step is we want to get a 0 in our first column. Okay, so the best way to do that would be to multiply -3 by row 1, add it to row 2. We can store that result in either row, so we want the 0 in row 2, so we're going to store our result in row 2. So we'll take the -3 and multiply it to row 1. I'm going to write what those are because, again, I need help with my mental arithmetic. 1 times -3 is -3. -3 times -2 is +6. -3 times 2 is -6. Okay, so here's what that gives us. Remember, we're storing this result in row 2, so I'm going to leave 1, -2, 2 as my entries in row 1. And let's see, when we add those together, we get -3 plus 3 is 0. -6 plus -5 is 1. -6 plus 9 is 3. Terrific. So now this isn't in reduced row echelon form. This is in a form we call row echelon form. So row echelon form has 1s on the diagonals, 0s underneath those 1s, anything you like above the 1s, and then numbers after the equal signs. What's nice about this row echelon form is it took less matrix work to get here, but let's see, what we have here in the bottom row is the equation 0x plus 1y equals b, or in other words, y equals b. Now, if I change that question mark up here to be a number, let's make it C. Then we have 1x plus cy equals a. And what we can do is if we have it in row echelon form, we can take the value we get for y equals b, and plug it into the other equation. So, for example, in this one, we have the equation now, y equals 3, and the equation above it is 1x minus 2y equals 2. So instead of doing more Gaussian elimination to get it into reduced row echelon form, we could take y equals 3 and plug that into the upper equation. So that would be x minus 2 times 3 equals 2. X minus 6 equals 2, so x equals 8. So a lot of times, we have the answer now, 8, 3. A lot of times, getting a matrix into simply row echelon form, where you have 1s along the diagonal, and 0s underneath those 1s. 1s along the diagonal and 0s underneath those 1s is plenty to figuring out what the answer is. On the other hand, if you wanted to, you could keep going and get it into reduced row echelon form to solve. So just so you have as many examples as possible of Gaussian elimination, I'm going to pretend that I don't know the answer is x equals 8 and y equals 3, just for a little bit more practice. So let's say, I got a little too aggressive there. Let's say that we're going to keep going, getting a 0 where the -2 is. So we'll continue, get it into reduced row echelon form. Okay, to get a 0, let me highlight this up here, we're going to take row 2, multiply row 2 by 2, add that to the top row and store it in the top row. Store that in row 1. Okay, so we're storing our answer in row 1, not in row 2. So I'm going to leave this bottom row as 0, 1, 3. But I am, for the sake of my little brain, going to multiply everything in row 2 by 2 here. Whoops, but I'm going to do it in a blue pen. So 2 times 1 is 2. We already wrote down 2 times 3 is 6, and 2 times 0 is 0. So I'm doing those blue numbers added to row 1. So 0 plus 1 is 1. And 2 plus negative 2 is 0. And then finally, 6 plus 2 is 8. And since we have this now in what we call reduced row echelon form, where we have 1s on the diagonals and 0s everywhere else, then we know that the 8 and the 3 correspond to 1x plus 0y equals 8, or x equals 8, and y equals 3, which is what we had a couple minutes ago. X equals 8 and y equals 3.